Hello Math 2, this is Mrs. Bricky and this video is for Unit 1, Lesson 2. We're going to be talking about exponents and monomials. So in class we had students work on this, but I'll walk through it with you. You've learned exponent rules in the past, but we just want to refresh on those and make sure you understand why the exponent rules are what they are. So you can see this first line is completed for us. So if we have t squared times t to the fifth, that means that we have two factors of t that are multiplied by another 5 factors of t. So altogether, if we expand that out, we can see that we have 7 factors of t. So we would write that as t to the 7th. So now I have an x to the third, which is 3 x's being multiplied together. That shorthand just means that we have an x times an x times an x, and we're multiplying it by an x to the fifth. And I guess the one above shows some parentheses, but I'm going to just leave it without parentheses here. And so if we see how many factors of x in total we have 8 factors of x, so we can represent that with an exponent of 8. And the last one has a y squared, so that's a couple of factors of y multiplied by a y to the third, so that's 3 more factors of y, and that gives us a total power of y to the fifth. So if you look at the exponents on the left, you can see that they add together to give you that exponent on the right. So the operator that goes in this empty box is that we add together the powers. If we have a base a with a power m multiplied by base a to the power n, that is base a to the power of m plus n. We add those exponents together. If we have an exponential expression like this w squared, and that expression is raised to the power of 5, we can also expand that. This means the 5 means that we have 5 of these w squareds, 5 factors of w squared, and the w squareds are each a w multiplied by another w. So we've got a w multiplied by a w, and we're multiplying by that 1, 2, 3, 4, 5 times. So that's a grand total of 10 factors of w, so w to the power 10. Here's an x to the third to the fifth, so that's an x to the third that is multiplied 5 times. And you can see when we expand this out that we have a grand total of 15 of those. So that's x to the power of 15. And then we have a y squared to the third. So y squared means y times y, and we have a power of 3 on that. So we've got 3 of those y times y's all being multiplied together. And you can see that that is a total of y to the 6th power. So again, if you look at our powers in our expression on the left, you can see that the power we end up with on the right is the product of those two exponents. So if we have an a with a power m and we raise that to the nth power, it's a with the power of m times n. We find the product of those two exponents. So we did a little matching activity in class. If you like, pause your video and try it out so you can check yourself. I'm going to reveal the answer, so if you're going to do it, make sure you pause for a second right now. All right, there's the answers if you want to check yourself. And so the two properties of exponents that we will use the most in Math 2 are these two properties that we've reviewed. So make sure that you know when to use each of those properties, and if you do have a time where you're needing to use an exponent property and you can't remember whether to add or multiply, you can think about what exponents mean and you can expand them to try to get the answer. Okay, so when you add or subtract variables like this a plus a plus a, that changes the coefficient. When we're adding together coefficients might change. We have 3a. When you multiply variables together, we can see that as a change in the power of the variable a to the third. Another just super important note about exponents. An exponent always applies to the number or variable that is immediately to its left. So when I have an x with a power of 2, I know that means that my base x is multiplied by another x. Or if I see a 5 with the power of 3, I know that means 5 times 5 times 5. That number or variable is called the base. But if there is a grouping symbol immediately to the left of the exponent, that is going to be designating that group as the base. So I have a couple of pairs of expressions here that students often confuse or maybe have a hard time seeing the difference between. So I want to talk about them. So in this first case, the thing that is immediately to the left of this power of 2 is the 4. So the base of that is just 4. And so what that means, if I write it out, it's that I have a negative in front of a 4 times a 4. And so when I simplify that, I get negative 16. But in the one below, the thing that is immediately to the left of that exponent is a grouping symbol. That means this whole group is the base. So in this case, the base is negative 4. So that means I have a negative 4 that's being squared. That means it's a negative 4 multiplied by another negative 4. So that gives me actually a positive 16. Sometimes, and we'll talk about it more later when we're subbing in, but sometimes when people mean to sub this into their calculator, they forget the grouping symbols and they sub this into their calculator, and that can cause an error. Not a calculator error, but an evaluation error where your calculator is misunderstanding what you want it to do. So on this expression, 7x squared, you can see that the thing that is immediately to the left of that power is just the x. So on this one, the base is x, and then 7 is just a multiplier coefficient. This is 7 times x times x. We really can't simplify that. It really just kind of is what it is as a 7x squared. But on this one below, you can see that the thing to the left of the 2 is that grouping symbol. And that means this whole group is the base. And so when I have a 7x that's grouped with the power of 2, that means it's a 7x multiplied by another 7x, which is a 49x squared. So again, I have a different result in those two cases because they are different things. Okay, so just a little definition for us. Remember last time in lesson 1, we talked about that polynomials are expressions that can be written as the sum or difference of one or more terms, with each term being the product of numbers and or variables. So I've got this polynomial here, 4x to the third minus 7x. Polynomials are often classified by their number of terms and their degree. So this polynomial right here, it has 2 terms, and so there's a word for that we'll talk about on the next slide. But I have 2 terms. You can see the 2 terms are separated by that subtraction symbol. Terms are in a polynomial are always separated by addition or subtraction. And then the polynomial, this one right here, is degree 3. So we're going to talk about those 2 definitions, the classification number of terms and the degree. So first of all, when we're classifying polynomials by their number of terms, there's 3 main words that we use, which are monomial, binomial, and trinomial. If a polynomial has more than 3 terms, that's absolutely possible. We just call it a polynomial after that, and we don't specify a number of terms. But we often are dealing with monomials that have only one single term, or binomials that have 2 terms, or trinomials that have 3 terms. So we do usually name those. Remember that terms are separated by addition and subtraction. So this first expression right here, 2x squared minus 3x plus 5. You can see that it has a plus symbol here and a minus symbol here. So those are separating our terms. So this has 1, 2, 3 terms. So that makes it a trinomial. This next expression, 3m to the 7th power, there's no addition or subtraction in this expression, so that means it's just one single term, and we call those monomials. I'm going to go to this one, m to the 3rd minus 2. So you can see that we have a subtraction symbol right here. Terms are always separated by addition or subtraction, so this would have 1, 2 terms. So we call that a binomial. And now we have 6x to the 3rd minus 2x squared plus x. And you can see we've got a subtraction symbol here, an addition symbol here. So those are separating our terms, and we have 1, 2, 3 terms. So we got another trinomial there. And here I have an x squared, and there's no addition or subtraction, so that's just one single term. It's a monomial. I have a y plus 4, so you can see that plus symbol there, separating the terms. So this has 2 terms, 1, 2, and that makes it a binomial. And then finally, you've got this negative 15. So it is just one single term, so that is a monomial. It's called a constant monomial. Polynomials can also be classified by their degree, and as you go into Math 3 next year, you'll talk a lot more about the degree of a polynomial. It can reveal a lot of things about the graph of the polynomial. Anyway, the degree of a monomial is the quantity of variables that are being multiplied together in that term. So in my first monomial, 5x squared, I have a 5 multiplied by an x multiplied by an x. So you can see that that term has 2 variables that are being multiplied together, 2 x's. So this would be degree 2. My next monomial is negative 3x to the 4th. So that's a negative 3 multiplied by x times x times x times x. And so you can see that there are 4 variables there. So this is degree 4. And you might have noticed that at least for single variable expressions, that degree, the degree of the polynomial matches the exponent. If your monomial has more than one variable, like an x and a y, that doesn't exactly work. But we will primarily be dealing with single variable expressions. So you can look at that power to find the degree of the polynomial. So we've got an x to the 5th in this expression, so that's a degree 5. In this one, we can't see a power, but we can see that there is one x. And, if it doesn't have a power, we know that that's a power of 1. So this is a degree 1 polynomial or monomial. And then finally, I just wanted to mention we had the monomial negative 15 on the last slide, and I wanted to talk about its degree. If you think about that definition as of the number or quantity of variables that are being multiplied together in that term, you might notice that this negative 15 has 0 variables, and so that is a degree 0. So these were all monomials, and we could find their degree by thinking about the quantity of variables. For a polynomial that has more than one term, the degree of the polynomial is the highest degree of any one term. So we just have to look for the most powerful term in that polynomial. So for example, with those terms I had on the other page, if I put them together in a polynomial, this is my most powerful term, and so this is a degree 5 polynomial. And in this next polynomial, 6x squared plus 7x plus 19, you can see that the most powerful term, the one with the most x's, is this one that has x squared, and so this is a degree 2 polynomial. All right, so we're going to do some addition with monomials, and then we're going to do some multiplication with monomials. So I've got 4 monomials on the screen, And I have the question here, which monomials can we add together? And from prior classes, you might remember that we could combine this one and this one together. But the answer is we can add any of these together. Any polynomial, any monomial can be added to another monomial. It's just that sometimes when we add them together, we aren't able to combine them and they become a binomial. So when we want to add together two monomials, we have to think about whether or not they are like terms. And if they are like terms, which means that they have the same variable with the same power, then we're able to combine them. So if I want to add together the monomial 7x squared and the monomial x to the third, I can't combine them together because they have different powers or a different degree. And so the sum is a binomial. That's my answer. If I add them together, the answer is 7x squared plus x to the third. And in this case, I have a 5x to the third, and I want to add it to a y to the third. And again, I can't combine those two together. In this case, it's because they have a different variable. And so the result is the sum is a binomial. But if I wanted to add an x to the third to a 5x to the third, they have the same variable with the same power, so I can combine them. And remember, this x to the third is like saying I have 1x to the third. We just don't usually write the 1. And so when we combine them, we get a total of 6x to the third, which is a monomial. So notice that when we are able to combine terms, the coefficient changes, but the power didn't change. They were both x to the thirds, and so when we add them, we also have an x to the third, but we just have a new quantity, which is represented as the coefficient, and so we now have 6 of those x to the thirds. So here's 7 different sets of monomials that we want to add together. Some of them will stay binomials, and others we can combine. So we want to think about, can these two terms be combined or not? So since these two right here have different variables, they cannot combine, and this one would just stay a binomial. For our next example of 4x plus a 3x, they both have the variable x with the power of 1, so we can combine them into the monomial 7x. Our next example has a 2x plus an x squared. They do have the same variable, but the powers are different. This one is power 1 and this one is power 2, so we can't combine them. They stay separate terms, and so we have a binomial answer. For the next example, we have 3b squared plus an a squared. Those are different variables. That means we can't combine them together. So this answer is a binomial. For our next example, we have 5r squared plus r squared. Remember, if we don't see a coefficient on a term like this, it's a coefficient of 1. So this is 5r squareds added to 1r squared. They have the same variable r with the same power 2. So this would give us a total of 6r squared. So that one has a monomial answer. For the next one, we have an x squared plus a 7x squared. Again, if you don't see a coefficient, it's a coefficient of 1. And these do have the same variable x with power 2, so we can combine them to get a monomial 8x squared. And then finally, we have an x squared plus 1. The x squared variable, the variable x is present in this first term, but the second term is just a constant. So we definitely can't combine those two terms, and so we have a binomial answer. Now let's switch to some multiplication with monomials. Back to these two monomials, we have a 7x squared and an x to the third. Can we multiply them together? Can we complete the operation 7x squared times by x to the third? And If yes, what is their product? Well, hopefully when you see it written here, you realize that we absolutely can do that. We can actually always multiply together two monomials. And in this case, the product would be 7, and we need to just use our exponent rules to simplify this. It would be 7x to the power of 5. So when we multiply together two monomials, we get a monomial. Sometimes both of the monomials that we multiply together might have a coefficient. So if you do have a situation like this where you want to multiply together a 3x squared by an 8x, you need to remember that multiplication is commutative. And what that means is that the order that we do multiplication in doesn't matter. For example, if I wanted to do 2 times 19 times 5, I could do 2 times 5 times 19 and I'll get the same answer. So the order that we multiply doesn't matter. So maybe not on paper, but in our brain, we think about multiplying in an order that helps us simplify. So for 3x squared times 8x, we might think of it as 3 times 8, which gives us 24. And then also x squared times x, which gives us x to the third. And then our answer, we've got our answer, 24x to the third. Notice that when we multiply monomials, we can now have power changes or degree changes. So I had a degree 2 monomial, I multiplied it by a degree 1 monomial, and my result is a degree 3 monomial. All right, so I've got some monomials. I want to try to add them. I want to try to multiply them. And again, if we're going to add, we have to have like terms. So if I have a 9x and a 2x and I want to add them together, I can identify that yes, they are alike. They both have the variable x. And so I can combine them to get 11x. If I want to multiply a 9x by a 2x, I would use that commutative property of multiplication. 9 times 2 is 18, and an x multiplied by another x gives me x squared. So this is 18x squared. Now my two monomials are 5x squared and an x. So if I want to add those two monomials together, I have to recognize that even though they both have the variable x, they have different powers. So I can't combine them. So our result is a binomial. So I'm just going to circle it because I can't simplify it. If I want to multiply together those two monomials, I can do it 5x squared times x, and this would give me 5x to the power of 3. And then finally, over on the right, I want to identify any terms that can combine. So I've got 4 different monomials here. I've got some addition and subtraction, and I want to see which ones can combine. Well, when we are wanting to combine like terms, we look for the same variable with the same power. So this one has an x with a power 2. This one has an x with a power of 1. This third one has an x with a power of 1. And then the last one doesn't have any x's. So the two that are alike that I can combine are these two. The other ones aren't alike and can't combine, so they will just stay in my answer. So I have 4x squared. When I combine these, I get negative 6x plus 7. And remember, when I add together that negative 8x and the 2x, it doesn't change any of the powers. I'm just combining those two with the new coefficient. Okay, so you may have a paper assignment from your teacher, or you may have an Edulastic assignment from your teacher. So make sure that you get your assignment done. And if you're not sure what your assignment is, check with your teacher for that. Thank you.